Hello, everyone. Happy weekend. I'm Jason, and this is the Astronomy Show. Tonight, we'll be talking about SETI, the search for extraterrestrial intelligences. Hope you all had a great week. We went to go see Spinal Tap 2. I wouldn't personally recommend it for anybody, but I saw it today, and I laughed at the end of it. So, but it was good to see them reunite for one last time. But I wouldn't recommend any of my family members to go see it. So there you go. We will be talking about life in the universe, and specifically the search for life, and more specifically new searches that are ongoing right now. There is the Breakthrough Listen and Breakthrough Initiatives project that is almost in its 10th year and of searching. And I did a deep research on that today, actually this week, all this week, and wanted to share with you some of the things that I found in that. You guys know I've been interested in the subject for a while, but and have a lot of historical information about it, but I wanted to bring myself up to date on what's going on out there. So we one of the things that Breakthrough Listen is doing is, so what is Breakthrough Listen? It's a project that came out of the Breakthrough Initiatives organization, and a Russian oligarch named Yuri Milner had donated $100 million to Breakthrough Initiatives to try to come up with a bunch of breakthrough initiatives, not only in the search for life in the universe, but also in how we could accelerate exploring the universe too, with spacecraft and speeding up vehicles to get to a significant fraction of the speed of light. And this Green Bank telescope that you see in back of me here is one of the telescopes that they've rented time on to do some observing. So on the Green Bank telescope, they've searched near the galactic center in a number of different bands, but in the X band, where they didn't find any signals worth investigating further. And they also have observed numerous galaxies. One of the things I looked in on was a survey of 97 galaxy targets, and they didn't. Hey, Steph Lurks! Yay! Good to have you here, Steph. You're first in chat. Welcome, and hope you're doing well and having a great week so far. And the subject tonight is SETI and the search for extraterrestrial intelligences, and kind of an update on what's going on now and even what's coming up in the future. And we might talk about what's been done. We will talk about what's been done already too, and where do we go from here, kind of thing. So the search for technologies basically is what it is. What a lot of SETI researchers would call technosignatures. And in this dish in back of me, it's the largest steerable radio telescope of this size, of this frequency range in the world for for what it does. In fact, all the telescopes that they're doing well. Glad to be here. Nice. Fits with the Mars news this week. Yeah, yeah. There was a story out about the potential for some footprints of life, and Anton Petrov did a great cover on that. Let me give a link to those in chat. Let me just close this for a second. As some of you know, I have to always close YouTube now because I don't go in logged in, and it just shows the most ridiculously bad images in the shorts section usually. So, and they did this time too, unfortunately. Ooh, I could snooze ads. I got this. I got it. And okay, so let me look this up. And here we go. Here, over to his channel here. Whoops. Sorry, Etta. So here, let me reopen this window here. Hey, 900. How's it going, 900? Good to have you here too. And it's the maybe not intelligent life. Yeah, bacterial life at Stecflurks, and that was you know, this story here. NASA just announced life on Mars. You know, basically, click me, kind of a title there. But let me copy that into the chat window here. There we go there. So that was that thing there. And so the other thing, another interesting story was this TRAPPIST-1e analysis, which basically didn't find any atmosphere to speak of substantial, although there were hints of possible methane on it. You know, it was, you know, it's not out of the noise enough to be sure of what's going on there. So yeah, that was an interesting story there. And yeah, let me see, 990. Thank you. Subscribe with, thank you very much, 900. Thank you very much for subscribing. Very appreciated there. You're awesome. And thank you for being here too. Last Miles, I'm here such that we may communicate with the Atlas aliens. Also, how's your horoscope today? Last Miles. So yeah, so for those who are confused about such things, may I recommend some other sources, like the horoscope section of the newspaper. What's a newspaper? Welcome. That joke is tired. I shall cease and desist. No, it's okay. It's okay. You know, if it was good enough for my kids, it's good enough for you. so yeah. You know, that one never stops coming up. So I always expect. Yeah. See, 900 writes, I've been observing more sunspots all this week since last Saturday at Saturday night show, where you taught chat the many ways you can edit and sharpen up awesome sunspot captures. Oh, awesome. Very nice. Very nice. Yeah. In the free GIMP software. Yeah, too. Broken mug for some reason. Yeah. So it's so I've dropped it, you know, twice, right? The first time I glued everything back on. All the chunks are probably still around here somewhere, but you know, for that mug, you know, the day it broke was a bad horoscope for it. And here's, I got my robot mug here too. Got the mugs here. But yeah, I understand that people don't like, they don't, because of their environments, they don't know the distinction between astronomy and astrology, and also some people, think that it's the same thing or that it's, a science, but it's, it's steps away to get coffee. Yeah. Excellent, excellent. Yeah. so, yeah, broken muggbirds. So my kids, they're comedians, and they knew, and I had mentioned once or a couple times, I guess, that I used to do outreach, and people would, say, "How long have you been doing astrology?" and or similar types of questions, and there was a long period there where I just was like, I wouldn't correct them. I'd stopped correcting them, and then I would just talk about it and say the word astronomy, right, and just use the correct usage and let them, like, I didn't want to like shame them in front of people and make them feel uncomfortable or whatever. So but my wife is like, no, you have to correct them. So yeah, in the future I probably will use the carefully broach the subject depending on who the audience is, but yeah, it's all good. So this radio telescope here, the Green Bank telescope, is actually a replacement for one that collapsed a while ago, and it was also, like, it used to be that SETI wasn't allowed on most of the radio telescopes in the United States, and then Arecibo was like the one exception, and then what happened is, I guess funding got scarce, and when Yuri Milner's breakthrough initiatives came along and offered money for observing time. See, it's one thing if you're doing it like trying to get free time from observatory time on government scopes while you're competing with other astronomers. And it's another when you bring a suitcase full of money and say, hey, we want some time too, because they need, they're kind of desperate for money. So it's originally the SETI Institute didn't have the money to do the proper SETI, and didn't have the money to say, hey, look, we've got this big budget. Well, if you could allocate a month at a time on your scope for a SETI, or, just give us access to it, we'll give you some money. They never had that money. And then when, about 10 years ago, when Yuri Milner stepped up and said, hey, I'm going to fund not only stuff at the SETI Institute, but also we're going to look at many different spectrum of light. So what happened is, with the breakthrough listen, is they were looking at this telescope. They were looking at they're looking through the Meerkat telescopes here, which is an array of telescopes in South Africa. They were looking in the Parkes Observatory telescope too, and in the future they will probably, if he extends the grants, do more down under in the Square Kilometer Array, which is being designed and built now. But this one exists. This is a 64 antenna array that has substantial size to in collecting area, and they can synthesize many different beams on a single target in the sky and get rid of radio frequency interference from humans. See, the Green Bank scope. Yeah, so over here, you're right. Yeah, this was the GBT here. Yeah. This is the green bank here. This one. So this one, as you could see with the humans on the bottom there, the scale of this one is tremendous. If you hold on a moment, let me just try to open something here. Oops. Wrong one. Because I want to get this other window going too, so I can show you some other stuff. Okay, here we go. Here. So here it is in, whoops, it helps when I open it quickly. So, hilarious. Let's see, that's where you live if you're allergic to Wi-Fi. Yeah, Larius is right, because it's a radio quiet zone. Not only is this Green Bank telescope a radio quiet zone, but also these other telescopes are also in, the Meerkat it's in South Africa, but in what's they consider a radio quiet area. And so, they ask that people not use their cell phones in the region. And, they have the scientists try to shield their microwave ovens and not do silly stuff. But, so let me see. Jason, in your cosmic travels, have you ever run into a good source of reliable but inexpensive solar filters, say for a 4.5-inch Newtonian reflector? Or do you know of any material I can make my own? Yeah, so definitely, a lot of people use the Bader solar filters, and we'll come right back to the SETI here, but just to close this thought. So the most inexpensive ones I can think of in the 4.5-inch range would be, and you can see High Point has it here, Bader at High Point here. This is a 70 here, but whoops, and so $55. So you might look around here at High Point because you're in the U.S., but also. You can, Bader Planetarium in Germany also sells stuff too. Like if you want to look around over here, let's see if we can get into the film here. So they do have glass filters too. So here, for those in Europe, this will be good. Here you could see these. They have 80 millimeter, 50 to 100 millimeter OD on this one, 150 millimeter here. That's 6 inches, right? And that's from 39 euro on these, but that's in Europe. So yeah, you might check High Point or some of the other ones, but I would start with Bader for solar film. Yeah, for sure. Yeah. And if you wanted to make your own, Bader might sell the film kits too. Astro Solar Film OD 3.8. So they do have. They're not much cheaper. I see it over here. It might be this one here. Might. Let's see. Yeah, telescope quality for imaging, right? So it is intended to use well-experienced astro imagers. This material is not intended to serve for protection for visual solar observing. So, this one here, this is something that you could cut yourself if you were so inclined to do that, or you could buy like a pre-made thing, which isn't much more of a thing too. So yeah, there you go. So, I see Yogi. What do you think about the latest life on Mars news? Hey, I see Yogi. Yeah, that was even brought up above. And 313. Hey, 313. How's it going? Can't use one. Welder's. Yeah, don't use. Don't use. The welder's helmet glass doesn't work very well. I bought them before, and they don't work well at all. Yeah, there are some, I forget the number. So they're different darknesses. Some of them are like super dark and good enough to protect you, but the darkest ones are, but they're horrible for looking at the sun with. Like you really can't see much with them. Yeah, so I wouldn't do that. And yeah, I see Yogi. Missed the notification this time, but glad you're online. Oh, thank you, I see Yogi. Yeah, we just came on, so we're pretty good. 20 minutes in, I came on a little late. I was pulling in references here for the stream, and I went to go see Spinal Tap tonight, and this afternoon at 4 p.m. And yeah, I would not recommend it actually, but give me a moment here. Just let me pause this for a minute here. I just want to open up, get into my email for a second. Let's get it, guys. So I pop this open. Oh, I don't want to go in here. Yes, I do. I want to go in. Oh, no, I don't want. Maybe I do. Okay. Sign in. Give me a second here. I just want to get a photo real quick for my email. All the prompts that they try to do now to get you to sign in. It's like too much here. Okay, there we go. Thank you. And then let's give me a moment. I do want to get out of this. Okay, thank you. Okay, we close that. Very good. Okay, good. Okay, let me reopen this here. Yeah, so so let's see. Crazy story. I live about 1.5 west of Green Bank, and went there. And I was about. This is Cell is saying this. 15, and the guy that was explaining stuff about it, I asked him after you picked up anything interesting, and his reply to me was, we've seen stuff you don't want to know about, which stuck with me. My grandfather was there with me, and we always wondered about what that meant. So that's an interesting Cell. Yeah, so I don't know what he meant either, but stuff like that would leak out. What he might be referring to also is, they accidentally intercept reconnaissance and military things too. So, maybe they were thinking of that too. But yeah, I've been reading the results, right? So here's the Green Bank telescope here. You can see for scale what a car looks like next to it. Oops. Let me go check my phone is on here. Let's see. Oh, okay. Google giving me a security alert here. It's like, thank you, Google. Let me just answer this. Okay, I gotta shut this off, guys. I'm just gonna shut my phone off altogether. Hold on, let me sign off here. So I've shut down. That's gone there. So yeah, we usually I like to shut it down before the stream, and then sometimes I get like it will distract me sometimes. The You can see the scale, right? This thing's huge, ginormous, and you know, it could be seen from a pretty high altitude too. And if you look at the region, it is beautiful. Very green region there, and it's what's supposed to be a radio quiet valley too, is my understanding. So yeah. If you pardon me a second, let me. Yeah, here it is. Here. Okay. There. So this one. So we'll look back on those things a little bit later too, but like the sites. But yeah. Let's see. Yeah, I've stood under it. It's incredible, right? It's amazing, right? And scale. So the one that collapsed was catastrophic. I don't know if I could find the article for that, but yeah. Oh, so here is this still? Oh yeah, here is the prior one. This is the collapsed metal of the 300-foot telescope. So you could see in the past it did have a catastrophic collapse. And here it says November 15th, 1988. And how it looked before was this one here. Let's see. We could show it here. It looked really cool, actually. So will this open? Well, I'll just embiggen it here. So you could see it over my head here. It was kind of cool looking. And then, before, after. So let me try. I can scoot this up here a little bit. And let me move Jason out of the way here for a minute. So you can see how it used to look. It was a sizable, a nice scope before, but that was before, and that's after. Like it wasn't good. So very catastrophic collapse there. And so great that they have replaced it with this beauty here. And let's see. Oh wow, it looks like an expensive collapse. It was. yeah. It was, but this thing looks kind of robust. Here, I bet they were probably like, we want you to engineer the most amazing off-axis Gregorian telescope that you possibly can. So that's what they did, and it looks cool. I don't know, maybe this will collapse someday too, because it does look pretty built. I don't know about overbuilt, but definitely has support. So this breakthrough initiatives, right? These guys they've observed here at the Green Bank telescope, and have looked at the plane of our Milky Way galaxy. They've looked at 97 galaxy targets at least, outside the Milky Way. And then have looked. There are other. Let's see. I probably should open the article for that because. Let's see. Do I want to do? Where's the breakthrough list in here? I probably want to open up the breakthrough list in here just to show you the targets, because it's pretty interesting. And they list them like, let's see. So here it is here with the Green Bank telescope. For all 1,000 stars of all spectral types within 163 light years of us, right? 1 million nearby stars, and that's the I looked in on a SETI symposium that where they were kind of talking about this too, and that the 1 million nearby stars thing uh, uh, is not in the Green Bank telescope. It is under breakthrough initiatives. So there are other telescopes that they're using, including the Very Large Array telescope, which we talked about recently, and these other scopes, right? They're using LOFAR, so low frequency radio, beneath 1,000 megahertz, like in the tens to hundreds of megahertz. They are here. They show that they've looked at the center regions of 100 nearby galaxies, include spiral galaxies, and actually that was reduced to like 97. I was watching what happened. They couldn't look at all of them, but center regions of at least 100 nearby galaxies, including all the type. They wanted to get like a broad sampling, so they looked at spirals, ellipticals, dwarf galaxies, and irregular galaxies, exotic stars, and there was a paper too of an exotic stars search, right? That included 20 white dwarfs, 20 neutron stars, and 20 black holes. And you might be like, well, why would they want to look next to those? Like, what aliens could live next to those? And you could imagine like machines being sent and perhaps manipulating a neutron star, which are, even though they're incredibly dense, they're very small too. And same for white dwarfs. Like you can perhaps find a way to modulate their emissions by dumping stuff or shooting stuff at them, or modifying them in some way that could modulate the signal. So they were looking at that. Black holes too. And Hetspoochie, good morning, Hetspoochie. And look, aggregate missile designs. Hey, Collapso. Let's see. Wow, that looks like, it was an expensive one. Definitely at Steph Lyrics. And last month, excuse me, did you say 1 million stars within? No, that 1 million star survey is within 1,000 light years. So that's different from. So they have different projects that came under this breakthrough initiatives thing. So the breakthrough listen is at UC Berkeley, right? At Berkeley, and they were the people who originally created SETI at home, and they had a lot of experience, and about 10 years ago they took this on. Yeah. So, okay, 1,000, much larger radius. Yeah, possible 1 million stars, I guess. Yes, at last miles. Yeah. So, let's see. What mega week with discoveries on Mars? Yeah, it's spooky. So I accidentally, I see Yogi and Steph and perhaps someone else too, had mentioned this Life on Mars thing. So we did, I don't know if this is still in my, is it still here? Yeah, I did. I put a link up above to the Mars story, which is this one, I believe, that was from Anton Petrov about them finding, signs of what looks similar to life. And we don't know of any other ways of making what they were seeing the way that we were seeing them. So our explanation on Earth for what they were seeing was that it was microorganisms. Yeah, Grok says there are between 40,000 and 55,000 stars within 160 light years. Oh wow, very nice. But ask Grok how many are within 1,000 light years. But yeah, it's I think on the order of a million stars, something like that. So at least in this survey that they did, and yeah, so let me back up a little bit. So there are other, like I mentioned, the very large array. So there's this thing called cosmic SETI too, which I don't think I pre-opened a tab for that one, but let me open that up too. Might as well. All right. Cosmic at the SETI Institute, and Cosmic is also here. So let's see. So here you could see Cosmic SETI Institute unlocks mysteries of the universe with breakthrough technology, and by breakthrough listens help subsidize that too at the very large rate. So for those of you who were here recently, I think I misplaced my book again. I don't know where I put it. Oh, here it is. I set it over here. So for those of you who saw Contact, the movie with Jodie Foster, right, and Matthew McConaughey, so written by Carl Sagan. So they weren't allowed. The SETI Institute was not allowed to do SETI on this array that you see here. But when Breakthrough Initiative came along with some money in their hands, they're like, yeah, sure. And so they are doing what's called a commensal search. So it's piggybacked. It's really awesome. The data, comes in from these telescopes, and they have different configurations for them, and it is compiled in a data center, and then because there's so much coming in, I forget how many gigabytes per second are coming in. It's like I forget the number. It's an amazing number. So all they can do is cache 5 minutes of the data. That's how much data is coming in. And they have a really big data center and a back end there, but it's or head end, if you will. But it's immense. I forget the number. It's many gigs per second. It's like 96 gigs per second or so. It's an amazing number, and so they cache it for 5 minutes, and the system goes through and looks for signals and will save snippets of that 5 minutes of data, right? It'll save snippets of it as candidates. They get millions and millions of candidates in that 5 minutes. They get millions of candidates. So the problem is throwing away the stuff that you get, right? And the bad stuff, and trying to remove the human-made interference, and it is very, 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 very hard. One thing that SETI has proven in all the years that it's been doing it is that it is almost impossible to deal with, if not impossible. I mean, they've proven so far that it's impossible, but it's almost impossible to get rid of the human-made interference. Yeah. It was totally wrong that time. Oh wait, what did it say? Google says it would take 1 year, 11 to look at one for 1 minute each. Yeah, well, it depends. At Willie, it depends on how you do the like what kind of arrays you're using and how big their field of view is. For something like this, it's a very narrow fields of view, right? But they have a very long baseline too, so, and a lot of collecting area. But there are other telescopes that are different, right? There are let me show you. I think we're going to do a tour of these things. How do I feel about the Highlander film 1986? I haven't seen that. Hey, welcome, Dead Internet Theory. I haven't seen that movie at all. But yeah, I remember what's his name, who used to play James Bond, right? Wasn't that? I think, I'm not sure. Don't don't quote me on that, but yeah, I think so. Yeah, 12 million. Oh, okay, there you go. 12 million. Yeah, ask how many are inhabited. It will say none. but yeah, Sean Connery. Yeah, there you go, Sean Connery. Yeah. So yeah, let's see. Grok says, yeah. There you go. So yeah, Hunter is a classic. Yeah, very good, very good. So you know, all of these, right? We were talking about breakthrough initiatives, right? So there, it was announced. Here it is. Here you can see with $100 million in funding and thousands of hours of dedicated telescope time on state-of-the-art facilities. That could never be done before they would get hours of dedicated observatory max a year, not even days before, right? And so what they've done is they've created this data system where they can go in diverse data sets, and this stuff is open source, so it's available online, all the candidates that they find, and there's a free software too, which maybe we'll talk about that soon too. So I mentioned LOFAR, which are low frequency radio stations. There are 52 stations, 38 of them in the Netherlands and 14 of them in Europe, that are searching in between 110 and 190 megahertz. I took some notes over here. There is open data, which let me see if I can copy this into our window here. I don't know if this link will work, but okay, it doesn't work. Okay, so that used to be, let me see if I spelled it right. SETI, berkeley.edu. Yeah, I know that, like, they were starting to lock everything down. Open data breakthrough. Let me just see if this, here it is here. So they maybe they just want people to come here to look through the data. So here's the open data archive, right, where one can go in and retrieve data from their, here. Let's see. So here they have the green. Oh, you can't see that. Wow. I don't know how to capture this window. So anyway, I'm going to call it out since it's not showing. So they list in the all projects window, breakthrough listen at Green Bank, automated planet finder, and breakthrough listen at Parks, right? But there are other projects too. So let's just do a search. Oh yeah, if I don't limit it, it's probably going to be broken. So yeah. Oh, here it is. So here they've got old data from 2016. Let's go to page 50 and see. And this is also, now this is exactly the same as the last time I looked in on this. So i.e. nothing new here, but I looked in on a symposium within the last 2 years where, let me get that link so that you guys can actually watch this. Let me close this for a minute here. I mean, it's kind of slow going, and not won't be everybody's cup of tea. Uh, let's see here. Um, oh, here it is. So, whoops, we blocked the audio on that, and see sample data. I'm just trying to pull this thing up here. Okay, so let me reopen this window here. There we go. So I'll give you the link to this one here. Copy this in here, paste. There we go. Whoops. There we go. So this was a 2023 symposium. So students come in and report on projects that they worked on over the summer. I just knew that. And some of them, the talk in here, it comes from work being done at Green Bank. There are a couple other symposiums on YouTube you could find too. Look, it only had 280 views in 2 years, right? But this is the breakthrough, this breakthrough listen group here, right? They have tutorials here for them, and they have a 2024. I didn't see this one. I did a search. I did a direct search for this one before, and it didn't give me anything. So I got to watch the audio here. So hold on, let me just pause this.
So welcome.
Oh, okay, thank you. Let's see, where is this? There we go. So I have to watch this. I'm not going to watch it now, but there are people from all around the world who are participating in this. So whenever you hear somebody say SETI as if it's a monolithic organization, it is not. It is many organizations, a number of universities, private organizations, not-for-profit organizations, and cooperating oftentimes, and so here, this is fascinating to me. I'm definitely going to want to watch this. Let me probably I should bookmark it here too. So here, which one is this? Oh yeah, Sapiens. I saw one of these in the 2023. I did a search for this before. Ooh, look at this. This is for transiting. Oh wow, look at that. That's cool. So that let's see, which one is that? Tufts high frequency, and then I saw here this an occulter here. See, search for Dyson structures. So that's the other thing that they're doing is this. They're studying. So they're looking for alien megastructures, right? They were looking for stuff that's in the, and this was in prior years too. In TESS, which is this transiting exoplanet survey telescope that is surveying, looking at exoplanets, but looking for in the light curves for dimming and like the characteristic features that would happen if something were not perfectly spherical. So if anything deviates from the round, right, which is what most planets are, that gives a slightly different curve than a regular bell curve, right? It has a more square kind of presentation, and so they're looking for this breakthrough initiatives is not just using low frequency telescopes, high frequency telescopes, gigahertz telescopes, but also looking in optical and in optical not just for transing megastructures, but even in the solar system, looking in, they've done modeling already of how artificial vehicles might look in the Vera Rubin Observatory scope, and could they characterize like the Tesla car flying in space? And it turns out that they could. Let's see. Good evening. Hey, Star Traveler. How's it going? Yeah, good to have you here. So yeah, like talking about contemporary SETI, like the place to go is this breakthrough listen and breakthrough initiatives. And the other thing, so breakthrough listens using very large array, right, in New Mexico, the Meerkat array, low FAR arrays, which are big, the Allen Telescope array, too. They're funding. Now, the Allen Telescope array, a lot of people think that the SETI Institute's telescope is dedicated 24/7 to SETI. It's not. So, do I have? Here it is here. So here, this is the Allen Telescope array here in the background. You could see these scopes here, these dishes, right? And so light comes down to the electromagnetic spectrum, right? Photons is not only in the visible, like in light that we see, but also goes, into radio spectrum, microwaves, ultraviolet light, infrared, X-rays, gamma rays. And so they're looking, these scopes can look, these are scopes that focus the light, this frequency of light, right? And bring it to their offset Gregorian telescope design too. And so the light comes in from an angle above and gets reflected to there's I think it's a non-periodic log array inside the receiver. I hope they have a picture of it. You see, it's so cool. I hope they do. Please have one in here. So here, not this. Oh, okay, they don't have a picture of it. Here's a side view of it. I'm going to go look it up because you really have to see it. So here's how that offset Gregorian design looks, right? Originally, it was going to be, these satellite dishes were from a certain vendor, right? And they I forget if they're like 18 feet. I forget their size. They're small, right, relative to like Green Bank. But it's what the SETI Institute could afford. They could only build 42 of them out of 350 that they wanted to. So they didn't have enough money to do it. But luckily, things have moved on since then, right? So that's yesterday, right? That's how things were. But with this breakthrough listen, they've basically bought their way. Here you could see, oops, where'd it go? Oh, here it is. Here you could see, like, these were the phases that they were going to build the array in, and it stuck at 42, which, of course, we like the number 42 here, but not for SETI. So it is, in some ways, it was a groundbreaking system because they learned how to integrate all the signals from multiple separate scopes into one scope, into one view, so they have a beam forming, right? And it was really a groundbreaking thing because the SKA, which is the square kilometer array, is a sort of a different Gregorian offset. But if you look really closely at the design, you could see that the similarities of the SCA design to it's just flipped around, right, to the ATA. So really, the ATA was a like a forerunner that kind of tested and proved the technology. I met one of the engineers who used to work on that, and I had him speak at my astronomy club many years ago, and he gave a nice talk to the club, and this is probably back 15 years ago, something like that. And let me see if I have an image of that here. Just give me a minute here. I mean, why? Because why not? Okay, let's see. Here. Okay, so here, this one here, this was, we had Billy Barrett come over to my club and speak, and he would be there in the summers, right? So he's a professor over here in Florida, and he would go here in the summer to the SETI Allen Telescope Array in the summer and help them with this beam forming technology. So if you look here in the background, it says Allen Telescope Array there on the left, and SETI Institute and Embry-Riddle, which is his university that he teaches at, or at least he did at that time. But yeah, so there's a relationship between this new upcoming array called the SCA array. It's a square kilometer array, and there are reasons that they designed it the way they did. But basically, these dishes will be spread out over this area, and there is already an existing precursor, intended to be, a potential forerunner to it, is this Meerkat array. So the Meerkat exists. It has 64 dishes up, 64 dishes. So here you can see this image that it has shot already toward the center of our Milky Way in the radio spectrum here, and you can see these cool features that are remnants from explosions, and really awesome. So here, let me show you. There should be a Meerkat. Maybe there isn't. I wonder if we can find this thing called. Hold on a second. I got this. I got it. There it is. So here, look at this. This is in Google Maps. This is the Meerkat telescope already, done. If you look down here, you can see, what does this design remind you of too? And the edges are linear, like it's a sphere, but it's built, it's done. And what they're doing is they're synthesizing their commensal, the SETI, the Breakthrough Initiative SETI program is getting data. So other scientists pick targets in the sky, and then they it's not listening like we do here. It's more like image forming in a way. Uh, um, but we like to say listening because, it depends. You can interpret everything, as an audio file or a visual file, depending on how you want to interpret things. Right? But basically, commensal means piggyback, right? And uh, they essentially, and they, other researchers look at a spot in the sky and they can beam form and change, even though their main target is a specific thing. This is true at the VLA too. Even though their main target is a specific thing, they can re-steer in the field of view off axis. You can see other perspectives too. I wonder, this one, I don't think I'd see a graphic for that here. Maybe the guy who's doing Cosmic did a YouTube on that. I'm not going to watch the YouTube, but let me see. He might have a graphic in there because I want to show you this beam forming thing. So happy I closed the window now for that. Let's see. Yeah, I don't see it here. Let me do beam forming. Two years ago, maybe they have a graphic for this. I'm gonna try to open this to see. Just give me a second. I gotta watch the audio on here. Oh wait, I'm close. I'm close. Whoa, thank you. Hey, oh, hey. Hold on, let's see. Do they have? Oh, they don't have a graphic in here. Oh man, they get into a talk of it, but they don't show any graphics of it. What a world! What a world! Okay, so it was a SETI talk, but without the beamforming. Okay, I'm closing this. Sorry, black screen doesn't work well here. So let me just reopen this here. A Clockwork Chocobo, MMU fly through. Thank you. I the great retro rocket fly through. Thank you, thank you, and thank you, a Clockwork Chocobo, and thanks for the lurk too. Awesome. I the great, welcome. I the great, and greetings. It is I, says I the great, and Star Traveler. Also good to have you here, Star Traveler, and everyone, everyone. So yeah, so this thing exists, right? And this is another of these arrays that is being used right now to look at the sky. I wonder, yeah, maybe a good idea would be to go to their site for that. Do they have? Oh no, they just have the optical here. Okay, let's see. See, I wish, I know I've seen the array images. Let's see if I can find it here. Let me just see here. Images here. So here, let's see. This one might work. Here. So here you can see it in its environment here. of how they looked on the ground. Really nice. But also that let me open up something else here. Let's see. So yeah, let me back up here. So let me also talk about the Parkes telescope too, because the Parkes they did do a multi-beam survey. They had 120 million hits in this one short survey they did, and they were using a convolutional neural network deep learning search for narrowband technosignatures in the galactic plane. So that was over here. Wait, did I close that window? I hope I didn't. Let's see. GBT, Green Bank. Oh, here it is. Here. So this is the one, and it's called now named the Muriang telescope, and but this is down at the Parkes Observatory down under there. You can see, see it there, and that's where the famous BLC-1 candidate was from, which turned out to not be a real so Breakthrough Listen Candidate 1, so BLC-1 was this first thing. Let me steer you over here. Okay. So here, let me just open up this. I did a video on the BLC-1 a long time ago. Here. Okay.
Hello, I'm Jason Higley, and I'm going to speak with you about the signal that was received from Proxima Centauri, a signal that was named by the Breakthrough Initiatives Project founded by Yuri Milner. It was named the Breakthrough Listen Candidate 1, or BLC-1. And they found it using the Parkes Radio Telescope in Australia, which recently was renamed Muriang, just as an FYI. And a number of signals were detected within a 30-hour period of observing runs that appear to be in the direction of the next closest star after our sun, Proxima Centauri. A lot of questions surround the nature of this group of signals, and the people involved in investigating it are reportedly writing 2 papers related to it. So we may get some definitive answers.
So we have some, I'm going to stop this. We do have some definitive answers, and the answer is that it was, it was human-made interference, so RFI, and that's the problem, is that we keep, we get millions of candidates, and it always ends up being us. And so, what they're proving basically is that, and look at this, back then when I made this video, the data went up to 2018, but we just checked it now and it only goes to 2016 now, at least on the one we were checking. Let's see, Breakthrough Listen at Parkes. Let's see, what were my parameters? Proxima Centauri. And here it says 2018. So let's open that. Let's reopen that, because it seems like they have less data there now. Let's see. Let's see. All file types. Let's see. It's going to be proxen. Oh, look, they have a bunch of targets here. Let's see. Oh, good, 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 good. Okay, so they do break it down by the targets here, which I saw Galactic Center go by before, and then they have specific targets here. Let's just pick, just see like what's what. Let me go. Uh, let's see. I see diagnostic runs in there too, and oh, fast radio burst. So let's just click that and see what comes up here. So this is nothing to show. Okay, I guess we'd have to set some more parameters. Proxen was the one that we put on that video. Here it is, Proxen. Here we go. Search. Nothing to show, and let's go back here. So our settings were these are our settings down here. Let's see. Proxen, no dates, all file types, right? So you see that, right? So I used breakthrough. I'm reading through my text here. This is back then, right? Breakthrough listen, all file types, no other fields, Proxen, and it gave this 2018 date on here. But going in here, so that means they've removed data, right? Because we just did that here, and nothing is coming up in that search result. So there you go. So that Proxen was data that was like the target was Proxima Centauri, right? And that was kind of the problem with this thing was that it turned out that it was it wasn't ETs, right? It was like just it was just us. So yeah, kind of interesting there. Yeah, so there you go. Let me re-chat here. Near Ray on the dark side of the moon. Yeah, you're right. That's a thing, right? That's an idea, which you could see in the background going there too. The in 1915, these thoughts were had too. So there are plans for a lunar like ideas for a lunar far side telescope, and maybe that'll come around, maybe it won't. We'll see. Just give me a second here. So I had that off axis. I was clipping the images there. Sorry about that. So these were just in the background on that video, but we'll go right back to the talk here. Let's see. Important decisions. Yeah, we need. Yeah. Hey, yeah. Yeah. So, oh yeah, is it a radio telescope? Yeah. So don't worry about the all caps thing. I'm not like people are sensitive about that. I'm not like it doesn't read the same way to me. It is more likely to get my attention, if anything. So yeah. So yeah, there we go. So yeah, Willikin had mentioned this lunar far side stuff, right? So they're like ideas for putting stuff on the far side too. Let me close this out here. So yeah, let's pause. I think I want to close it all actually. Okay. There we go. So, yeah. It's funny, they have a link here for it. Yeah. Here, right? I'm clicking it. Foresight tells you. There are dark ages. We know about that, but they only have the XREF here. That's interesting. Let's go to the NASA thing. So here, Lunar Crater Telescope in 2021, they did an article here on NASA. And so the idea would be to send these little robotic probes, like rovers, to drag cables over a crater and deploy a dish in the crater. And then, because it's on the far side of the moon, it would be shielded from Earth's radio frequency interference, right? And so you can see here this tension cable that they would pull over it, and they could even shield it from the sun too, and the Earth, because the sun is a significant source of radiation too, for like radio instruments, and if they wait till lunar nighttime, that would be awesome too. But they'd need some, like RTGs, like plutonium sourced electrical power production to run it in the dark, kind of thing. Yeah, the moon. So, it's so nasty to deal with. Yeah, and the dust, right? The dust is really tough. Yeah, Steph Lurks. Yeah. Oh yeah, yeah. The Corona Borealis is not erupting at this time, per American Association of Variable Star Observers. Excellent, excellent. Yeah. So here you could. So if they ever do this someday, this would be like one of the highest value science missions that they could do on the moon, is to build something like this, and they could see all the way back to the early, the dark ages, of the universe, like right, where we're, at the beginning of the universe, basically, like just after the Big Bang. So yeah, that's that one. I used to have. Let me see. I don't know if I have it here anymore. Let me look this up here. Hold on a second. Let me. Actually, I don't want to do that here. Let me try over here. Just looking briefly for some images that I used to have of the Lunar Far Side telescope. I don't know if I have them on here. Oh, I do. I've got, yeah. Oh, okay, I found them. Let me go get them. We're going old school. Well, let's see. Oops. Okay, so this is one. I have this locally. This is one of the early concepts here, where you could do an array, right? A lunar far side array of telescopes. So not just one, but do a number of them, and then you could do that beam forming that they do on Earth, and pick multiple targets. And what's good about this is you can go even further in mitigating R5. Why? Because there are some things orbiting the moon now, and eventually this satellite pollution will spread to Mars. Even there's already stuff orbiting Mars, so it's a problem. There are so many thousands of satellites orbiting the Earth now that it's almost impossible to do good SETI research. Let me see. I have one other, I believe. I don't want to do that. Let's see. Okay, this is the other one here. And like I said, we're going real old school here. So just bear with me. I don't even know if these are searchable images anymore out there, but with the internet being destroyed and everything. But here you could see, another concept with astronauts up there. It's kind of reminiscent in a way of Arecibo, right? The way that they were thinking about doing it, which, as a lot of you know, Arecibo collapsed catastrophically. It used to be a big SETI telescope. Let me show you that. That's just like amazing. If you just bear with me, let me go get that. And I believe folks went into ads, but let me just close this for here. Here. Okay. So yeah, this was just amazing. Full moon full of fiberglass particles. Yeah. Oh my goodness. Yeah. The moon, it is like you really couldn't, like, for optical SETI, right? You couldn't, like, you'd have to come up with some scientific way of getting the particles off of an optical surface, because they're just like insidious. They get all over the place. Yeah. But here's this thing here. And this is when the Arecibo collapsed. It was sick. There's other angles to include, Jason. Just ducking out the cables there. So, yeah. This was the Arecibo collapse. Yeah, heartbreak, right? Just like unreal. Like, how do you let it get to this state? Watch the other angles from the drone where the cables fail. It's so amazing. So here's the drone footage of it. So they had a drone up next to it because they knew it was failing. And went doink, 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 doink. No audio on that, but look at that. Just like unreal. Damn. And that's just like unreal, right? So folks who just came back from ads, I'm going to replay this for you because it's just like so amazing. So this was the collapse of the Arecibo observatory, which used to be used for SETI. Yeah, this is historic. Yeah, very, yeah, very, yeah, very, yeah. So yeah, and then the drone, for those who went into ads, there's a drone footage from above, which shows the cables fraying and popping, and then the collapse. And this was, the pride and joy of American science, right? The biggest radio telescope in the world at that time. And the Chinese, well, did the Chinese finish fast? They might have finished fast by now. I think they did, actually. But it was at one time the biggest radio telescope at one time. And so, yeah, you could see, like, so dangerous, too. Oh, my goodness. Luckily, no one was killed, I believe, in that. But it was something else. And you could see the dish just, like, laying there, collapsed down, and not cool for sure. Yeah, that was a tough one there. But yeah, I'll give you the link to that there in case you want to see that up close for yourself. There, it's something else. That was something else. So yeah, let me. Yeah, Anta Petrov did a great video about this telescope. Oh, really? Yeah. So, the Chinese built a new telescope, right? That actually, like I was telling you about UC Berkeley before, some SETI scientists there gave them some advice for the Chinese fast telescope. So, except there's a problem. So, so the 500-meter aperture spherical telescope. So here you see it here in China, and let's see here. So unfortunately, I heard Jill Tarter during some meeting recently where she said that they built an amusement park nearby this, which, would be catastrophic from a radio silence perspective. I don't know if that's, like, I would assume that was true, but I wonder if that'll even show up in here. We could try China. I don't know. There it is. Yay. So here it is here, right? From above here, you can see it. Awesome. And let's see, can we see the amusement park is the question. Okay. Don't know that we could. There's an elementary school. Okay. Jason lost it. How do you lose a 500-meter telescope, Jason? Like this. Okay, there it is. Okay, let's back this up here. So I'm just going to look equidistantly and see, like, what are the main... There's some kind of thing there, but doesn't look threatening to me. Oh, there's a viewing platform over on the right. I don't think that it would have been... But there is a lot going on over here. Yeah, there's a lot of people. That's a lot of development over here. Which, seems like it would be pretty close. But yeah, she was saying they put an amusement park over here, which I don't know where it is. I don't see one that's like really ridiculously obvious. What's this here? Yeah, I don't know, but they were going, like, one of their stated missions here was to do SETI, like that, here too. So there is some kind of Chinese SETI project going on. You know, I don't have any information about it. I don't know if this or, you know, like the Wikipedia article would have anything on that. Let's see. Even though it's 500 meters, it says only a circle of 300 meters is useful at any one time. Let's see, 70 megahertz to 3 gigs. Let's see. Oh, so it does say that they have a 5-kilometer zone that forbids tourists from using mobile phones and other radio emitting devices. But yeah, so I'm not sure like what's just Jill Tarter was saying, but Jill Tarter is a SETI, like, arguably the most famous SETI scientist on Earth, and yeah, I'll take her word for it. Here, so this woman here is, you know, best known for her work on the search for extraterrestrial intelligence. Tarter is the former director of the Center for SETI Research, holding the Bernard M. Oliver Chair for SETI at the SETI Institute. In 2002, Discover magazine recognized her as one of the 50 most important women in science. And she knew Carl Sagan, and that's why have the contact book here. Okay. Where did I just was showing you guys? Oh, here. So the character for Ellie Arroway was very loosely based. Not even loosely. Like, Carl Sagan knew Jill Tarter and wrote, you know, like when he wrote his book, he had her in mind, but she has said that he, you know, he was really, that Ellie Arroway is him, is what she said. I saw her, an interview with her recently, where she said that that Ellie Arroway is him because he would have liked to have spoken with his father one last time, like at length, and yeah, it's kind of the the contact story, right? So yeah. Oh, look at that. Okay, I saw a con. I was like, wait, is that SETI con? No, it's CSI con. So yeah, I've shown you guys my SETI con badge here. This is my SETI con badge for let me show you here. So this is SETI con, Team SETI, and it was. I'll read the date because it's a little out of focus here. Let's see, Hyatt Regency, Santa Clara, August 13 to 15 to 2010, and you know we've shown a few images from that in the past. I'm going to try to stay on target here. Stay on target. Excuse me. I have to hydrate. Excuse me. Excuse me. Really cool. Oh, thanks. Yeah. So a while ago I had gone to SETICon. I wonder if I should try to open a slideshow of that. I'm gonna make it on the fly here, so I don't know how well that's going to go. Let's see. Loop is good. Hide it when done. Just give me a second. I've never done this while on stream, so this could be problematic. We'll see. Here. Give me a moment. I'm going to try to open it here. Where is it? This. Let's see. Okay. So in the back here, oops, let me. This is a slideshow from there. It's not a slideshow. It is a slideshow, but it's just like me adding a folder in here, unscreened. So it's going to fly through a bunch of images that are in that folder right now. Hopefully, nothing bad in there. I had a junky point and shoot camera, and that's Frank Drake, Jill Tarter. That's Frank Drake there, and Jill Tarter and Seth Shostak together on the stage there, and a bunch of other luminaries from the SETI Institute too. Zillions of out of focus images in here. The things you're going to see in here will, some of them will not make sense, but this is everything from my that's in that folder there. So you could see here we're going to fly through stuff. I'm going to keep, I won't look at chat for the moment because that way I can narrate stuff going through here. Let's see. Yeah, so just a bunch of talks by different people, different panels. Like I said, out of focus stuff. Lots of out of focus stuff here. Let's move Jason out of the way here too. Where's my... So, that's Tim Ross. Hold on a second. I got to pause it here. Hold on. Where is it? Where is it? Oh, here it is. Okay. Pause. Okay, let me back this up. So that was Tim Ross. There. That's... Okay, I'll be right back, everybody. I'll be here back in 30 to 45 seconds. Hold on. Hey, everyone. Sorry. Yeah. So that's actor Tim Russ. If you ever heard of Tuvok from Star Trek Voyager, right? That's actor Tim Russ. He's an amateur astronomer who was at the conference and giving a talk with everybody there. I also he was also played with the band, with the NASA Ames band, because he's a musician too. So this was at SETICon. So all these are at SETICon. I'm going to fly through here. You could see, well-attended rooms of people here. Let me just see the details on some of these here. So yeah, some of these were like Doug Backcoach and some of these other people who worked at the SETI Institute too. Let me fly through here. So no one's ever seen these images, like these whole room images. No one's ever seen them before. So these are all from that conference. Like I said, a lot of out of focus junk here. Here, Kepler planetary candidate orbits. I had a really messed up point and shoot camera with me, and this was in 2010. So quite a while ago. Here you could see Kepler was a spacecraft, right, that went up and found thousands of exoplanets. So this was a talk for that. Lots of junky photos in here too. But there you go. Let me just fly through here. You could see well-attended conference, a lot of people in the talks. There's Frank Drake and Seth Shostak, Doug Vake Coach, and I don't know who that other guy was. But they also were debating. I have some videos in here of them debating and, hashing things out in front of people too. And Seth Shostak making arguments like, we've already given ourselves away in our position, so it doesn't really matter that we communicate with others in the universe. And so that's Frank Drake of the famous Drake equation on the left there, and Seth Shostak on the right there. And oops, sorry about the red eyes. There's Jill Tarter there, and the guy on the right, I think, is he from the Planetary Society? He might have also been from a radio show. Is that Ira? I can't remember his name. Anyway, let me fly along here. So there's Jill chatting with people too. Frank, like I said, lots of junky images. That one was okay, where they're talking with the public. I think I showed you guys before my Drake equation thing too. This guy traced a meteor all the way to the ground. So we look at meteors on stream. This guy followed, you see the photo in back of him. It's in the Wikipedia article too, where he traced all the way to ground this meteor that's in his hand right there. And you could see it down there too. And he wears a glove, even though I'm sure it's been handled, but kind of preserves it still. And so if you want to see that up close, I'm going to see, it should hold up to some scale here. Let me just try to open this up here. Here you can sort of see inside that one there. I could probably make it a little bit bigger. Won't look too great, but there you can see inside that chunk that he's holding there. And we were all, you could see the Hyatt paper there. We're all at the Hyatt for this conference here. And then let's see. Oh, this is on the way I was flying there. These are not going to be interesting. These are just on the flight. We were flying over. I was on the way there. Let me just see. So actually, it was a beautiful flight. These are just like unrelated photos here too. And oh, you could see the sign of humans here, and interesting how they can turn such a desertified looking area green too, with well water, or redirected water, I should say. I don't know if it's well. Might just be river redirected. These were like some kind of weird military site that I don't know what it was, but they had all these different nodes there. It's kind of weird looking. Yeah, so this interesting river. We came in through Colorado, I think. Had to go to like Denver Airport too, and I just thought the landscape was kind of beautiful on the way over there. Let's see the rivers carving the earth up there. It was fairly pretty. Never shown anybody those images before. So here we're coming in. I think we're coming into Denver or something. This is at Denver Airport. Oh yeah, this is in Denver Airport too. And so there you go. Oops. Southwest. Got the moon out the window of the plane there, which we also went over a thunderstorm too. Let me just hurry up here. From the plane. Like I'm doing astronomy from the plane. So silly. Let's see, let me hurry up here. We're almost done. That was on the plane. So even though we're on the plane, I could still make out what was on the moon. There you go. And that, and there were some great videos of thunderstorms too, which are probably in that folder too, but I don't think they'll play in the slideshow here. Anyway, that's it. That was that. Now that wasn't all the images from SETICon, but it was some of the interesting ones. There were a lot more. I'm gonna remove this from the playlist here. Let me just get this out of here. Delete it from the here. There we go. Yeah, so let me just see if there's one other image that I might want to show from that trip. Before we were talking about the lunar far side. Well, I don't want to. I probably shouldn't do a history of SETI thing right now because I really wanted to stay focused on contemporary, like some of the contemporary stuff, at least here early in the stream. But we did touch on the lunar telescope. Let me show. Here's another idea that they had for the lunar telescope here, which was to protect it from the dust too when they bring it there. It was another idea to possibly do come up with different schemes for this. Let me close this here. And yeah, so there you go. Let me look in this folder and see if there's anything of interest here. Okay. Yeah. Oh, okay. Oh, that's interesting. Yeah. Oh, this is a great comparison here. Oh, I think I like this. So one of the things, like we were talking about the lunar one. So why would you do a lunar, like use a lunar telescope, right? So here on Earth, this lower chart shows the window of visibility of frequencies, right? And then the noise and where things are blocked from our perspective into the universe. So here on the left, you could see degrees Kelvin, and what it means is that there's this thermal noise in the background, right? And it's lowest in this range between 1 and 10 gigahertz down below here. But if you go up to space, right, the window is a little bit wider in space because you don't have to deal, well, a lot wider, because you don't have to deal with the noise from oxygen and water and these other atmospheric, constituents that cause you problems. So in the upper one, if you put something on the moon, right, you're dealing with, you actually can see a lot more stuff in space. So if you put a gigahertz range or higher telescopes on the moon, you can, above 10 gigahertz, you can see more than if you tried to do that from Earth. So, maybe what if ETs are only communicating on those higher frequencies, right? We couldn't penetrate the atmosphere well in those frequencies, so we would never hear them at all. Versus these the lower one here, where you could see the H and the OH down at the bottom there, and that the OH on the there, that range, that's what's called the water hole, right? And it's for hydroxyl. It's between hydrogen and hydroxyl, and that's considered a range that perhaps some SETI scientists thought would be where different species in the universe might convene. Water-based species, on the premise that water is a foundational thing for life. You can see there are other H2O. There are H2O blocking aspects in our atmosphere, but over there, the hydrogen, what happens in space, hydrogen is everywhere in the universe, and astronomers who are extraterrestrials will also look out at hydrogen in the universe. And so the idea is that maybe they communicate somewhere around hydrogen, or a multiple of the frequency of hydrogen, the spin flip frequency. So hydrogen emits radiation at 1420 megahertz, right? Or 1.42 gigahertz, right? And there's a range up to 1.7 gigahertz that between hydrogen and hydroxyl, where they call it the water hole, that where maybe ETs, and that just so happens to fall in this optically clear, radio optically clear window in the sky where we can see out into space better than at other frequencies. So let's see, is this about the Mars news thing? Hey, aren't you? How's it going, aren't you? Good to have you here. No, it's not about the Mars news thing. It's just we're talking about the search, right? And new searches too. Let's get back to our talk here about new searches. So, we were looking in, let me close this here, and maybe we'll go image diving on some other things later, like old school stuff. But right now, I want to kind of get back to the new searches, right? So this breakthrough initiatives, right, is because of this billionaire oligarch donated money uh, to different organizations, but headed up at UC Berkeley is where. So UC Berkeley is where SETI at Home was originally run at, and is the headquarters now for this Breakthrough Listen, which is using many telescopes around the world. So the LOFAR telescopes, there are 52 LOFAR telescopes. There are, if you give me a second, I don't know if, okay, I do have a link here for one of the ones. I don't know if this is going to work. So, this is supposed to be at NANK. So, in theory, this might open on it. There it is. Ooh la la. Hold on a second. This is in France. Let me get on top of this. Here. So here you can see one of the LOFAR antenna sites, right, where they have these arrays of telescopes. So in this particular case, the let's see, do I have? Yeah. So this Nenufar array works at between 10 and 85 megahertz. That's a frequency range that no SETI researchers would ever even dream of looking at in the past, because it is so full of terrestrial noise. And you would have to be emitting from your system at amazing power levels to be detectable over interstellar distances at this frequency range between 10 and 85 megahertz. But this is one of the sites that that it has that. So if you hold on a second, let me copy this link in here. Yeah, too noisy, right? Oh yeah, for sure. Yeah. I'm thinking, making this. Ooh, yeah, big this. Oh yeah. Too noisy, right? But it is one, like, they are throwing everything at the wall and seeing what sticks, basically. So there are, I had mentioned there are 52 of these LOFAR array setups around the world. Let me see. Yeah, 52 stations, 38 in the Netherlands, 14 throughout Europe, and those are searching between 110 and 190 megahertz. But this particular one here is they're doing a search here on Nenufar at 10 to 85. And then let's see. So before we're showing this green bank here, and Breakthrough Listen was did a sampling of our Milky Way from between 751 megahertz, which is still less than a gigahertz, right? Less than 1,000 megahertz. It's 751 megahertz, sort of like where UHF TV stations used to be, sort of, almost. Like emergency frequencies, actually, it is what it actually is. Like, if you have emergency services in the US, a lot of the trunking frequencies are in the 700s. So they were looking with this scope between 751 megahertz up to 11.2 gigahertz with this scope, and looking at a broad sample of nearby galaxies to see if there were any civilizations emitting at undreamable levels. Yeah, but they have to look, right. You got to look to rule stuff out, right. So another thing they're doing is studying not just the interference from the satellites, because there's so many that go by now, but also what would extraterrestrial spacecraft look like if they were transiting through the solar system, and what kind of presentation would they give. And one of the studies, optical studies, was that they would be able to distinguish using the Vera Rubin Observatory. They could characterize something as small as the Tesla that they flung out into space. So I thought that was kind of interesting. And they even did like some of these transit studies of stars where they showed that if anything wasn't round, that they would be able to figure out that it wasn't from the curve of it. And maybe they're looking for technosignatures, right? So they're looking for Dyson spheres and Dyson swarms, and some kind of artificially created relics, right, in orbit around stars. So yeah, let's see. At least it's cheap to build compared to higher frequency. Oh yeah, aren't you? You're very right, and that's exactly right, aren't you, about the arrays. So subtracting noise, right? So cosmic, right, which is another one, and then the one we mentioned at Meerkat, right, are able to distinguish. I think we closed out Meerkat here. Let's see. Let me back up here. I think I go back one more. Oh, here it is. Okay, so here, this is the Meerkat, right? Array, right? In South Africa. And they are doing separate beamforming with these telescopes. Like this, these are the new modern SETI in a commensal search. So the data, they can have multiple scopes look at different targets, but also if, let's say, a user is using a number of these to look at one target, in the software, they can do beamforming that looks at other targets away from the main target. And it's passive, right, in the sense that they have to go wherever the researchers are going. That's why it's piggybacked, right? So they're not actually controlling the direction, but this 1 million star survey is in part done here, and then the VLA, the cosmic, is supposed to also take part in this one. It says with over 500,000 sources observed in the first 6 months of this project, right? And so that's almost a million, right? That's 500,000 right there. And I think there was going to be they were doing an upgrade to the VLA. I don't know if it's started yet or not, but there's supposed to be a big upgrade coming to the VLA where they're making it bigger, and then this will pause. This cosmic SETI thing will pause, and hopefully, they go back in. And they were doing this VL. What was it? VL. I wrote it down here. VLASS survey, right, from the Very Large Array Sky Survey, and that's where they could get to the million candidates, I believe. See, Cosmic SETI is commensal open source multi-mode interferometric cluster, right? And data is from the VLASS survey. So if we go look here, whoops. Jason, what are you doing? Let's see here. So here's the VLA Sky survey here. Let's see. At epoch 4.1 commence. So that's good because it means that they haven't shut them down. And then the SETI guys can do, like, keep doing the commensal searching as long as it's not shut down for this upgrade, which is great. Let's see. There you go. You could see this is in a tight formation for this array here. And let's see, September 5th, it says here, on October, observations commenced for the final epoch of the VLA survey, VLASS 4.1. First pipeline generated images are now flowing to the archive. Ooh, quick look image cache. Ooh, what's this? What's this? Let's see. They're probably like fits. But I wanted like a guide to quick look images. Well, I'm just going to touch this and see what happens. I don't know how this is going to go. Actually, yeah. So, okay, they're tar fires. Yeah, they're fits too. So, good luck. I'd have to. Are there LBLs here too? I don't know if there are any LBLs, but yeah, I'm not going to train myself on this in real time. I'll look it up and try to figure it out because that looks like fun. Let's see, what's this over here? Interactive HIPS image containing all currently available epochs. Let's see. Interactive maps. Ooh la la. Ooh, okay. Ooh, what's this? Okay. Stegosaurus. Okay, hold on. Let's see. We'll drag this around. Don't see a lot going on here, but I'm going to try to zoom on some stuff and just see what happens if I really zoom in. Like ridiculous. Okay. So let's see. Yeah, maybe it helps if I press one of these down here. Okay, that should limit it, right? Let's see, because these are, right. Is there combined median stack? Let's see. Ooh. Ooh la la. A new toy to play with someday. I will someday. We'll look into. I'll look into this and learn how to use it. That would be great. Looks like fun. So let's see. I've worked a little with some Murchison wide field array data before. It was pretty awesome. Oh wow, yeah, yeah. Laser focused gravity guns have a special signature. Looking for battles, no doubt. Yeah. And so RNG was answering Cook Joe. And let's see. Some noise. Yeah. Subtracting noise. Yeah. So that's the great aspect of this thing too, because they can do multi-beam forming, reject the noise, and which is so bad. The RFI, for decades now, right? Even this thing had millions and millions and millions of candidates, right? That they couldn't follow up on, and it was all the RFI. Was the big problem with SETI at home, and then, if we look, this was for those who might wonder, like, what was SETI at home? This is I grabbed this off of the the Wikipedia article, but this is used to be able to have a screensaver on your desktop, and they would send you work units where from a telescope, right, and from real telescope data. And here you could see up on the right, well, you can't see it probably too well there, but it says recorded at SETI at home multi-beam, and the base frequency 1.41 point blah 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 1.419 blah 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 gigahertz. So you see it's 1.41 gigahertz. That's in that water hole frequency, right, of around 1.42 gigahertz that I was showing you before. So here, this is an example of that. So it would send out these work units, you'd process it and send it back, and then you'd get another one. And you would build in your account, you would have statistics of how many work units you've processed. And there were competitions of people, teams. It got up to 100,000 people. So far as I remember, 100,000 people signed up to run SETI at home. People were stealing bandwidth from the universities. Like there were like whole farms of computers on these competitive teams, and people were running them unauthorized at work and at universities, and it was slowing machines down because of all the work units being processed. And it was interesting, but it was something where you and I, average people, could get involved in the search. It was so in that aspect it was really fun, because you could help participate. And eventually what happened is they did start running everything locally instead of sending out the work units. But out of this program was the first successful distributed computing project, like the biggest ever and the most successful one. And since then, many other science projects spun out because of this SETI at home program, to where BOINC, which is the is where where you can here. So here you could choose projects, right, on BOINC today. Look at this list of things that you can run distributed computing programs on now. And you see asteroids at home, BOINC Central, climateprediction.net. Here, Dennis, let's see, studying electrical activity of the heart. Einstein at home, looking for pulsars, right? What else did they have there? Using data from the LIGO gravitational wave detectors. Not the Arecibo telescope, because that's gone now. But let's see. Gerasim at home. Parallel algorithms in the CAD for designing logic control systems. And so you could see all these other ones: Large Hadron Collider, Milky Way at home, cryptography, factorization of large integers, a bunch of math ones here for prime numbers, and radioactive distributed. Let's see, it says free and continuously updated map of radiation levels using sensors connected to volunteers' computers. You must buy a sensor to participate. And this is BOINC Poland, right? So there you go, RNA world, which, there was a big discovery recently related to RNA world. But, like abiogenesis, and Anton Petrov did a great science video recently pointing at that. I think it's going to be one of the most significant we're cool times, but really we need a successor really badly, says IC Yogi. Yeah, right. So yeah, so imagine all these things right here that I just scrolled through here, spun off from SETI at home. All these science distributed computing science programs spun off from SETI at home. So great outcome. But notice that SETI at home is no longer listed here. If we go down to S, you see it's not listed here anymore. So they do it all local now, and what's happening on these new things, right? So SETI, UC Berkeley, which ran SETI at home, is running. I'm not affiliated with them. Is running this Breakthrough Listen or Breakthrough Initiatives project with coordinating all these different student researchers, scientists from around the world, take this multi-pronged approach with private money. So that, some of these things are at universities, but you have to remember they are seeding real scientists. If you look at these SETI symposiums online, just look at the ones for Breakthrough Initiatives SETI symposium. So you do SETI Berkeley Symposium, and you'll find a number of the symposiums there and students that are speaking at the symposium. So they get a summer project, right? They're doing other stuff because they're students, right? But in the summer they get a project and they work on it for the summer. Usually they run out of time and they can't finish what they want to do, but you can get a sense of all the fingers or all the pots that they have going at this Breakthrough Initiatives project running at the same time. It's amazing, and which includes that we were pointing at cosmic SETI, we're pointing at Green Bank Telescope, we're pointing at them using the Green Bank Telescope facilities, using Meerkat, this Murchison Wide Field Array, right? This Parkes Observatory, the SCOG is got in the future, most likely the Allen Telescope Array in Hat Creek in California. Oops, sorry about that. So here's the Allen Telescope Array, and then let's see. Whoa. Okay. So here, I think I'll. Before I get away from this one, let's see when they updated their news. So here, let's see. So here, let's see. May 13th, 2025. Breakthrough Listen, headquartered in University of Oxford, is the most ambitious project to date, searching for technosignatures and signs of technology. So hold on a second. Hold on. So they moved us. Hold on a second. Let me see. Okay, so here, let's see. Oh yeah, so here it is. We're participating in the new Breakthrough Listen initiative to use Green Bank, Parkes, and the automated planet finder. Okay, so it's out of Oxford. That's interesting. I thought that it was all coming here, because if you watch the symposiums over here. Oh wait, I gotta close this. I'll show you in a second. So here, okay, let me pause this here. So where's this here? In this symposium here, let me bring this up here.
Strongest constraint.
So here, if you watch these symposiums from UC Berkeley, where they literally said where they're running them from, out of Ireland, out of Italy, out of Ireland, Italy, South Africa, Australia, right? What did they mention? Australia? Yeah, well, they refer to it, but the kids who are coming in here and doing their symposium presentations in here, you see it's 2023 Berkeley, and then we just found it 2024 before. All these kids from all around the world are reporting in on this symposium at UC Berkeley. That's why, like this woman here, I'm not going to open her big image here, but that woman is from Italy. And you see, and there are people from China, India, and in universities that are overseas. And interestingly, a number of them from Ireland, too. And one of the Ireland LOFAR students, they're all, they have their mentors at the universities, but they're reporting in here on this Berkeley thing. So that's what led me to believe that they were headquartered there. Hey, Twitch guy, how's it going? Yeah, I'm doing great, thank you, at Twitch guy. Let's see, I donated a good chunk of CPU time to SETI at home back in the day. Yeah, right. Let's see, Kung Pao Jeff. Wait, hold on a second. Hold on a second. I have to look this up. Can you hold on a second? Just hold on. Because I know somebody by that name too. So let me just check this. Just give me a second, guys. Hold on. Oh, the mathematician. Okay. Interesting. American mathematician, engineer, and cryptographer, known as the father of information theory and the founding father of modern. Let's see. Father of information, then who laid the foundations for the information age. Okay, that was different. So someone must have edited the Wikipedia very recently. So yeah, that's cool. That's cool. Yeah, let's see. Oh, thank you. Yeah, 1939 Nobel Prize. Yeah, very cool. Yeah. So, yeah, these symposiums are they're students, right, giving presentations. Some of them second year, third year. I didn't see too many like fourth year in here in these, but it was interesting because they're learning real skills, right, for signal analysis, for astronomy, like doing pulsar research, doing galactic surveys, going into databases, extracting the data, some of them using machine learning, some of them not, right? Some of them just going algorithmically, looking for things, and like all different. They're throwing everything at the wall and hoping something sticks, I think. See, yeah, hell, I'd settle for terrestrial intelligence most days. You are correct. At Kenzai, of course. But yeah, I see people went into ads, so let me just there we go. so yeah, that was funny. So yeah, so that that's where I got that impression. But we were just reading where we read they were saying headquartered in where did they say it was headquartered in? Okay, so here, this one, it says based at Berkeley. So you see this one? Look at this. So here, we just saw something else that said something else, right? But look at this Wikipedia article. And here you could say the science program is based at the Berkeley Research Center. So there you go. I knew I read it someplace. So there you go. Let me just hydrate. Hold on a second. Welcome back from ads, everybody. Jason was not imagining this. Over there, for those who went into ads, there you can see it says the science program for Breakthrough Listen is based at Berkeley SETI Research Center located in the astronomy department at the University of California, Berkeley. So that's where I read it at, and maybe it's just not updated, or we saw like a contrary thing. I don't even remember where we saw it now. But it looked like they said it was based out of England, which it probably is. But let's see. So here it is here. So headquartered at University of Oxford on the official Breakthrough Initiatives website, right? So let's see. What I want to do is I want to pop this and see Westerbork, the Netherlands. Let's see, most ambitious project to date for searching for techno-signatures, signs of technology as indicators, partnering with Astron, the Netherlands Institute for Radio Astronomy, and the University of Manchester to deploy a new all-sky monitor at the Westerbork Observatory in the Netherlands. The new experiment takes phased array feeds, essentially wide-field radio cameras, that were previously deployed on the Westerbork Synthesis Radio Telescope and installs them on the ground, looking up at the sky directly. So there you go. Just another one of these wide field things. If you can look very wide in the sky, you can, or all sky, you can cover millions of stars, or everything really. So yeah, that's kind of cool. They don't do a lot of releases, apparently, but they do, like I said, they do have their hands in all kinds of things. So I'm guessing that maybe this Wikipedia article is going to be updated someday for breakthrough initiatives, and maybe not. But yeah, Berkeley's still doing it, apparently, at least according to this here. So that's cool. They still have the link for SETI at home, but this is dead. This is an old. They need to remove this because I'm pretty sure that this is over. See, there's the SETI. Oh, this is that's a different one. Yeah, this one. I have that logo saved someplace too here, but that's the old one. I'm gonna click this. Let me see what this link looks like. Copy link address. I'm just gonna look at this and see what it looks like. Oh, it just says download. I'm not gonna do that. Getting started. Okay. I'm gonna get out of here. That's what I'm gonna do. Hold on. Let's see. Our telescopes. Here we go. Green Bank Telescope, Parks, and Automated Planet Finder. Okay. Let's look at this one here. Whoops. So these are the tables. They're logs. Old version log. Dates on here. This is, a spreadsheet, obviously, of their, but I don't see any dates in here. It'd be funny if it did let his view only. Okay, must be logged into your Google account and request access. Okay. Oh, they're running this on Google Docs. Oh my goodness. Okay, where's this? I want to close this. That's what I want to do. Leave. Yes. Okay, and let's see. Read on. Let's see. Oh yeah, this was this is the same window that I was showing you guys. This transparency window, right? So here they have a simplified, like a better, in some ways, diagram of the same thing, where the penetrability of our atmosphere for observing in radio and microwave and gigahertz wave, and millimeter wave even, uh, uh, is best down here. So this, we're talking about 1.42, right? So over here, this it is near the water hole right here, right? And here you can see planetary radar is what the Arecibo used to be, and that's why they show that there. And spacecraft communications up here in the 10 gigahertz area, and this stuff here, this blue, it blocks signals. So where it's most transparent is down by the water hole. Yeah, I like the idea of searching for intelligent life, but fear the reality of humans finding it. Oh yeah, yeah. And who's ruining their home by throwing all this sticky stuff onto the wall? That's crazy, people. Yeah, so it's these guys. it's this breakthrough listen people who are just, they're going all out. They're using the VLA, the Green Bank telescope, the not the Green Bank Meerkat, which is like the forerunner of the square kilometer array, and then Parkes radio telescope, Allen telescope array, which is not, I had started mentioning before that the Allen telescope array is not a full-time SETI telescope. They use it for doing other things. Some of it radio astronomy, some of it. But yeah, let's see. With pulse modulation and gamma frequency, so much info is required. Yeah. When you get this information transmission thing is even a thing that the SETI scientists are not doing, right? They're not even trying to decode. They just want to find a a signal out of the noise, and don't even if they can show that it's extraterrestrial in origin and very narrow bandwidth, those are some of the characteristics. The other ones are, like the drift rate is one thing, right? Where you could see if it's on a planet, it's going to drift, and plus we're on our planet, so it's going to drift too, because we're moving through space and they're moving through space, and that's going to change the frequency we receive over time, right? Unless they can correct for it, and those would be some really seriously interesting aliens. But yeah, in theory, it would be possible to correct or get close to correcting for that, but it would take intimate knowledge of our Earth's, of everything about the Earth, and, our motion through space and our rotation speed and like all kinds of things. But it's possible, and so one of the things, like they have all these kids, college students doing these miniature SETI projects, right? And some of them are rejecting the data in them because they are not changing in frequency over time. And it used to be a thing years ago in SETI where maybe ETs are correcting for that. So somehow, like, some of these students didn't get that message, because really they need to look at all the domains. So yeah, there you go. So those are the 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 main projects that they were doing. Let's see. I wrote a bunch of notes here just to make sure I didn't forget anything. So yeah, so there's single dish observing, right? So that's with this kind of scope, right? And then the multi-dish ones, and the single dish, when a source is in the field of view, and they're pointing, right? They go on the source, they detect it, and then they point the scope away, and it should go away when they tilt it. If the source stays visible when they move it away, it's local noise, right? But it takes time to steer the scope over and then put it back. Steer the scope over and put it back. But the bright side is you have this single, well-phased antenna looking at the sky, right? But in a multi-dish array, you have a number of dishes that can be, when you add them all up, they can have a similar collecting area as this ginormous one here, combined, right? But are spread out over a much wider area, so you can get higher resolution out of them, or not, if you elect not to, right? So there's a benefit for that, and then the other benefit is that you don't have to point them all away from your target, because the diversity of the receiver antennas, right, gives you the ability to reject the human-made radio interference naturally, because it's in different scopes. Now, if there's an RFI source that would be common to all of them, then you're out of luck. Like if it's something in orbit that's, like, let's say it's a real noisy satellite, then they may all have pick it up. But let's see, otherwise, like, it's not a problem. But when they're spread out like this, like the ska or like the meerkat, right? Just see, we still have that open here. I don't think so. Let me just close this for a second here. Just see, is it still open? Yeah. Here we go. So here's the meerkat, right? This other array in South Africa. The user, someone's doing an observing run, right? And the user wants to use multiple dishes to look at a particular object. And because it's commensal, piggybacked, right? The SETI scientists don't have control over it. They're just riding along, coming along for the ride, and but they can beamform. So the main observer is looking at one target, but with this system, you can digitally in software aim it to other nearby spots, just like this cosmic project 2, which I think here it is. This one here is you can also, it's commensal, right? So it's piggyback, but you can also combine them to look at at off-target objects within the field, still within the field of view. So yeah, that's a new thing. It's kind of, yeah. They were doing beamforming on the Allen telescope array, and that's kind of where they best, and also in phased array, phased array antennas. But it got, like, for this scale and type of scope, these are kind of recent developments for big telescope arrays. Yeah. But yeah, they've been doing phased arrays for quite a long time, but not for radio astronomy. Not in this scale with these scopes. So let me correct that. For SETI, I should say. For SETI. For astronomy, the VLA's been around a while. But it didn't. Originally, they weren't allowed to do SETI at the VLA until Breakthrough Initiatives came with the money bags and said, hey, we want to buy some time here. And so it worked out well. Their commensal, the Green Bank telescope, they had pure time, like pointing time, like direct on the sky, pick your targets. You're the user, right? Not commensal. And then, but for these, they got them to get into the data feeds too, so, which is a great outcome. This is another of these, great results from, that have come up recently, like good fortune, because for decades and decades, SETI scientists have been lamenting, not having money. Even today, technically, the SETI Institute is not funded by, according to what I heard from Jill Tarter, and correct me somebody if I'm wrong, but what I heard her saying is that, like SETI, the public money that comes to SETI, the SETI Institute, is for the astrobiologists who are there. So they have 100 degreed scientists at the SETI Institute doing microbiology related stuff for astrobiology, right? And related studies, right? Not doing direct SETI, like that money, that federal government money, can't be used, as far as I know. Like, they're not applying it to SETI. However, the Allen Telescope Array is technically owned by UC Berkeley, even though the SETI Institute, designed and built it. It's really the Berkeley that owns the property. They own the Hat Creek property. They own the site, and they're for the telescopes, and so they allow others to use that array. So yeah, so there you go. And Allen Telescope Array is also, one of these projects that has been brought into the fold of breakthrough initiatives, to, like, they all need the money, right? Everybody needs the money, so, to run. So, and it's all, really on the kindness of billionaires and millionaires, right? Because, and don't, like, I get everybody's anxiety on these kinds of subjects, but originally, even before this guy came along, like, the reason the Allen Telescope Array is called the Allen Telescope Array is because this guy Paul Allen, the co-founder of Microsoft, put up his own money, the seed money. Here you can see it says $12.5 million, and the first phase of it was to be 42 antennas, right? And then he gave an additional $13.5 million to to finish the first and second phases, right? But to this day, it's still only 42. It didn't get up to the 350 units. You see here, it's at 350. Even although he contributed over more than 30 million, it's not succeeded in building the 356.1 meter dishes originally conceived, right? And in fact, it's much worse than that. So if we go here and we go here. So here you can see, it's a much smaller scale project. If you look at the buildings here, let's see, can we see any vehicles here for comparison? Looks like nobody was here this day. What's up with that? Wow, looks like nobody was here. Must have been a national holiday or something. There aren't any vehicles here. It's so fascinating. Anyway, you can see these are all probably parked too, because they're all pointing up, straight up at zenith. Well, actually, off to one, almost sunward, actually. But they're all pointing in the same exact spot there, except for this one. This is the BEMA. These are different. These antennas are not part of the Allen telescope array. These are a different kind of antenna for a much different purposes there. So there you go. Only 42, right? So I don't even know. Let's count it. 1, 4, 5, 6, 11, 12, 13, 14, 15, 17. I don't see 42 here. I don't see 42. Okay, hold on. So this is the Allen telescope array. Let's see. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18. But these look like BEMA. Oh, they're just in a different orientation. I thought these were the BEMA. There's a BEMA. Where is it? I don't see it here. So these other ones are them in a different. Okay, I get it now. So all of these. So yeah, it's going to be 42. I'm not going to bore you with that. Let me find. Give me a second, guys. I don't know if this will come up, but let me just see. So it did bring me over here, but I don't see it here. I have an old picture of it, and I'm not going to really bore you with that, but anyway, let me just close this out here. So let's see. It's spooky. Wow, this is a view where you live. Beautiful spot, I must say. Yeah. FBI and Jason's store. Hey, it's spooky. No, I heard a noise, but I don't think it's anything. So I'm not gonna. I was just checking to make sure I don't see anything of concern. So yeah, I heard a noise. So there you go. So what I want to do is, let's see. So, yeah, probably we'll wrap it up on this, the breakthrough initiatives. Let me just see if I missed anything I wanted to talk about. But yeah, so the meerkat, some of the things that I wrote down when I was watching these symposium, that the meerkat has 52 times greater field of view than the Green Bank telescope. It has a large collecting area, able to synthesize coherent beams on sources of interest, excellent RFI rejection, commensal, and when the signal is in other beams, surveying 1 million sources nearby. In radio quiet area of South Africa, 64 offset Gregorian dishes, a potential pathfinder for ska. So the meerkats here. Oops. Let's see. This one here, right? So this one is the potential pathfinder here, which just like the Allen telescope array, was also a sort of like a pathfinder for the square kilometer array. This meerkat also, is that, right? It is an offset Gregorian design too, and notice that they don't keep them in a regular pattern here too. Let me show you like the old idea that they used to have for the Cyclops array. So let me see if I can find that. Here it is here. Okay. So this was the original idea for the Cyclops array. So this was going to, planned to be, it was a study by NASA for an array, but they figured out that this pattern would not be a good pattern to put because it's too regular for the telescopes. So that what happened is instead they started like setting them apart and not having them in a regular pattern. They could easily, with all this clear land, could easily have symmetrically dropped these things, all over the place. But this was this old idea. It was called Cyclops. They're gonna have, what was it, 1,000 radio telescopes, I believe. Don't quote me on that number, but I think it was supposed to be like 1,000. So there you go. So that's true also at the SETI Institute's Allen Telescope Array. You could see that nothing is regular here at the site. It's all kind of odd. And even at the ATA, like if we look at the Atacama, oh wait, even better, look at it from above, over here. Here, you could see it looks a little bit regular, but the footings are actually irregular, right? And this is, they're not using this one, so far as I know, for any SETI programs, but you could see kind of the same thing, right? You can see the landing footings where because they move these things away to service them, and you could see where they R is not regular, like this one here. Welcome back from ads, everybody. Just looking in on a non-SETI array here to compare, that these array telescopes are not set in regular patterns like this old idea plan of the Cyclops array, which was going to be used for SETI 2. Never got built. It would have cost hundreds of billions of dollars probably for that thing. So yeah, so there you go. Let me go back over here. So yeah, what's another one? Let me think about this for a minute. So yeah, the Meerkat, right, was this one that has 60. Was it 64? I think there were 64 like total telescopes on the site, in a radio quiet. Yeah, 64 in a radio quiet site. Potential pathfinder for square kilometer array. Let's see what else. We looked in on the Nero SETI before, I think, which maybe we didn't. So there's an infrared. I don't think we did. The infrared optical SETI survey at Apache Point Observatory. It's called Nero SETI. See if I can pull this up here. So we're kind of in we want to look at contemporary, like what kind of SETI's going on right now, right, and in the future too. But here it is here. Here's Nero SETI here. Is an astronomical research program to search for artificial signals in optical, visible, and near-infrared wavebands of the electromagnetic spectrum. It is the first dedicated near-infrared SETI experiment. The instrument was created by collaboration of scientists from University of California, San Diego, Berkeley SETI Research Center, University of California, Berkeley, University of Toronto, and the SETI Institute. It uses the Anna Nickel 1-meter telescope at the Lick Observatory, situated at the summit of Mount Hamilton, east of San Jose, California. And I have to tell you, this Lick Observatory optical thing has been going on for a very long time. But let me read this first and see what this new latest aspect of it is. The instrument was commissioned in 2015. It's been operated on more than 150 nights and still operating today. So in the olden days, there was another at the Lick. I think it was at the Leuschner Observatory. I don't know if this Anna Nickel scope is nearby, but the Leuschner telescope and was another one operated by Lick, is my recollection. Used to have a cool in their like retro SETI. See if I can find. I have a folder here with old SETI project logos. Here it is. Here's the Lick SETI logo from decades ago. And so where'd it go here? So here you can see it here, like the laser going into it. And this was on their website like maybe 15, 20 years ago, whatever. But they've been doing this for a long time here. This was what it looked like before. Do I have? Let me show you. So there were SETIs from all around, like in many other places around the world too. We had Australian SETI. So here is SETI Australia's logo there. We had, let's see, this was the old SETI at Home logo here. that you saw elsewhere. We saw this was SETI, University of Kentucky SETI here. Here you can see the University of Kentucky had a SETI program. You can see ET there. Is that the old Green Bank telescope there? Not sure. Let's see. Let's see. We got SETI Italia here too, which they used to. I remember interacting with somebody from this a long time ago. So here, see, they used to be doing stuff, and let's see. Here's Argentina. Here, you can see. There. And, let's see. There was a SETI League, which still exists, too. Out there too. That's the SETI League. They're still out there, I believe. Let's see. Let me pop this open. This was Kentucky Optical SETI's logo, but it was just this image where they had like this Fresnel lens, and they were doing optical SETI with a Fresnel lens, because it doesn't really matter. Like you want to try to receive light over a large area, so they were trying something novel there. Let's see here. And this was okay. This is the I think they're still using this logo. This was the SETI Institute's logo. This is too low of a resolution, but there you go. And then last but not least, Nishiharima Observatory in Japan had this as their logo too, which was their observatory there too. So that was kind of cool. Let me close these all out here. So yeah, just some logos from days gone by of SETI projects too. There you go. So let's see. Yeah. So this, what got me thinking about it was this lick. Whoops, sorry about that. Okay, it's earlier. This one here is this SETI, this Lick Observatory animation on the 1990s style GIF there. And I know I say it funny for the young people here, but that's how it was in the older days. So yeah. So there you go. So yeah, we're talking about modern programs here. So let's get back up to this NeuroSETI is looking out there. Originally, they were looking at nearby stars that for flashes of laser light in the sky. They still are. And this got picked up into the breakthrough initiatives too for the funding. So again, because of somebody's generosity of funding these things, they're getting done, right? Otherwise, they wouldn't. They would, if people find ways, the researchers find ways to survive, but there's only so much you can do. So let's see. Here they have this list of targets here listed here. They said clear nights, 20 to 30 objects are observed on a clear night. Extensive stars, thousands of light years away. Initial target sample was originally stars, main sequence, and giant stars within 50 parsecs, drawn from the Breakthrough Listen program target list. So let's see. Here's the list here. Let's open this up here. Let's see what it looks like here. So let's look at the HR diagram. So they are diverse, right? Like through a wide selection there. Where's the? Okay, these are the wow. So okay, and they color code them. So this is all of the target stars that they had in their program from this list. Let's see. Integration times for a Green Bank telescope. Let's see. Oh, I wrote this down somewhere. Hold on. Where is it? Oh, yeah. So there was this other survey. They had this thing. It was anti-coincidence search for technosignatures using 2 long-wave array antennas. Each station has 256 dipole antennas, and the frequency range was from 10 to 88 megahertz, separated by 75 kilometers in New Mexico, with 2 modes of operation, all sky and beamforming. And it doesn't use the on-off method because you can, do the beamforming thing. The diverse observations help to eliminate the RFI. They would be narrowband search, and then they were using the software called SETI, which I saw. It's over on GitHub. It's a Python based search algorithm that all these kids were using in the symposium. But yeah, let's see. So what was I was telling you about this other thing, right? Let me see, where is it here? Anti-coincidence search, right? So in order for this particular one to be able to receive signals, this 10 to 88 megahertz survey, the effective irradiation power of the antenna transmitter has to be 10 to the 13th watts in order for it to be received by this antenna. So this is this other thing in SETI where, like, for some types of signals, you would have to fry your home planet to have like a all sky beacon, simultaneously, kind of thing. But that wouldn't, 10 to the 13th wouldn't, but it's a lot of watts there. So let's see. I want to look this up. So here says the search for extraterrestrial intelligence is a field growing in recognition and involvement as scientists seek to understand the possibilities of life beyond Earth. SETI aims to detect technosignatures, signals from extraterrestrial sources that may indicate intentional or unintentional communication from intelligent civilizations or evidence of their technology. Historically, SETI research focusing on radio technosignatures has primarily investigated 1.4 gigahertz to 1.7 gigahertz region of the radio spectrum known as the water hole, in part due to the presence of hydrogen and a hydroxyl emission line. So that's what I was telling you about before. On the other hand, areas such as below the 100 megahertz region are poorly studied, primarily as a result of technological limitations. However, low-frequency radio astronomy is expanding rapidly, with the construction of increasingly sensitive instruments, allowing us to broaden our search to relatively unexplored domains. Coupled with the greater field of view gained from low-frequency observations, we believe that below 100 megahertz region to be a worthy venue of investigation, and present our research as follows. In this study, we describe our anti-coincidence search for narrowband signatures, technosignatures at two tuning frequencies between 53 and 88 megahertz, which I believe is on my radio dial. So using two long wavelength array stations in New Mexico. Whenever Canadian hydrogen intensity mapping experiment radio telescope detects a fast radio burst, a network of subscribed telescopes, including LWA, are alerted and conduct observations toward the direction of the source. In a matter we have carried out 16. This is the exact symposium that I looked in on. 16 hours of data, and they analyzed. Let's see, for narrowband drifting signals with Turbo SETI and Blimpie and scripts. Thus far, I haven't found any. Research is still ongoing, and they plan to conduct a narrowband search in the future. So what I want to do is find this long wavelength array in New Mexico. I'll re-chat in a second. So I just want to get this in here. Here it is. Yay. Okay. Come on, baby. Okay, so here's another one of these arrays, right? I'm trying my best to scale this thing. It's not going well, but I'm trying. Let's see here. So here you can sort of make it out. It looks a lot like a LOFAR array does. Yeah. Arecibo. Can of banana da. Hey, can of banana. Yeah. Jason, how did I miss that you were streaming? I don't know. I think some people said they didn't even get a notification. So that's possible too. Yeah, Arecibo. Yeah, we looked in on Arecibo before at Canna Banana Dial, and it's collapsed. right? It was like amazing, right? Yeah, here it is. So, just give me a second while I'll lower the volume. Sorry about that. There's a placebo. There. Yeah. Catastrophic. Yeah. Oh my goodness. Right? Yeah. Right? Yeah. Something else. Yep. And wait, the drone view. For those who just got here, watch the drone view. When the cables are popping, it's something else. Catastrophic. Yeah. So yeah, there you go. I just wanted to show you guys. I don't recommend this this movie. Let's see. Oops. But tonight, this afternoon, and at 4 p.m., I went to go see this movie, and I do not recommend it. But I did get to see their end. So this is definitely their very last gig, and you know it at least we could say goodbye to them. So yeah, but yeah, misadventures at the Arecibo. Yeah, it was a tough thing. So that's why I'm kind of changing it up here. We have been talking about the 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 contemporary searches for so you guys never see me with my outside glasses on. Here you always see me with like reading glasses and stuff, but those are my that's what I usually wear outdoors there. And yeah, so two bad movies, Galaxy Lords and Spinal Tattoo, but I saw it on opening day, so at least I can say I did that. But I think what I liked, the only, like I only laughed at the very end of it, but I think the thing that I enjoyed was just seeing like them in the studio and music, like no spoilers, but about the ending, but you know, music, them performing, because there actually are musicians in real life. So that was me, silly me, going out there. Are the Galaxy Lords cousins of the Time Lords? No, I don't think so. So these are the Galaxy Lords over here. This is the Galaxy Lords here. So, right here. So these guys here. Let's see if what I want to do is just give you a copy of this link to the trailer is arguably better than the movie, but this is the actual Galaxy Lords trailer there. Once Broadway had people. What? Are you gonna start in again? Can of banana dial? Once Broadway had people. Oh, are you talking? Oh, you're talking about like the demise of theater. I think. I have to watch your references because sometimes I don't know what you're alluding to. But yeah, once Broadway did have people. Yeah, it's a shame that it was destroyed. Yeah. I had to sit through a half hour of ads and trailers, waiting. Like I went there at 4, like, silly me, right? And I haven't been to a movie theater in years and years. Like I asked my wife, when was the last time I went to a movie theater? It's been many years since I've gone. And I was like, okay, I'm going to do it for this. and it was ungood. It was, yeah, like I'm not going to say it's bad because I would like it to me, it was no big deal to be there. But I know for other people who are like really critical about movies, they will suffer through this movie. But for me, I enjoyed it because I've been following like the Spinal Tap story for a long time, and kind of this year kind of got re-interested in it again, looking at all kinds of amazing like arguably the all the interviews they've been doing the last few weeks on like all these different, it seems like it's coming from the same company, but they are doing and sitting in these sessions getting interviewed, and those were good actually. So yeah, let's see. Echo Motion. See, there will be Spaceball 2 coming out next year. Yeah. Excellent. Hey, Sir Didymus Engelwick Fezzik is here. Oh my goodness. Isn't that how it always is? They put all the good stuff in the trailer so you actually watch the movie. It's full of empty nonsense. Yeah, but this trailer is great. This is a great trailer. The best trailer ever. but seriously, what was I going to say? The trailers that they made us sit through were so unrelated to the Spinal Tap movie. Like numerous horror movies, numerous like strange, just like why am I suffering here watching these things? I literally asked myself this. There were a couple points while I'm waiting. It was a half hour of commercials, ads and trailers, right? Regular advertising, like just like regular advertising, and then trailers. And I was paying to sit in the theater, right? I put my head down a couple times just to like power through, like, when is this going to end, kind of thing. And it was so bad. It was so bad. Yeah. There we go. Do you see that there will be a Spaceballs 2 coming out next year? Yeah. We saw the trailer here, not on stream, but I mean, I've seen the trailer of it. It was, it looked kind of. I was shocked that Mel Brooks is still alive. But yeah, that was So I did go off target there. So here we are. You would think, yeah, with all the advertising revenue coming in, that people would get in free. Really, I mean, they should have paid me to go see that movie. It was like, it was so long. It was suffering. Yeah. So here we go. So what I want to do is, we've done kind of a review of the Breakthrough Listen, like all the Breakthrough Listen projects, I think, which include, going to the Green Bank Telescope, going to Meerkat Array, going to, we looked in on Nero SETI, we looked in on this anti-coincidence search, which we just looked at. There's a 256 dipole array there. We looked in on Cosmic SETI. We looked in on Parkes Telescope. We looked at that they're using TESS telescope data to look for alien megastructures. We talked about them using the Rubin Observatory images for characterizing um, um, uh, spacecraft or technology moving through our solar system. We also looked at these LOFAR stations that are 52 stations in 38 in the Netherlands, 14 in Europe, looking in new frequency spectrum that were never, SETI's never been done in these lower frequency range, and even these very high frequency, because these go up to 11 gigahertz here on the Green Bank Telescope. So, like, SETI hasn't been working in these field areas before, so there is the potential of discovery, great discoveries coming up, and out of these, what is the most expansive search ever done. Now, the problem with like these million star surveys, is that the sensitivity is not high, right? It would take an Arecibo kind of telescope by the ETs to be transmitting. Arecibo used to be the largest planetary radar on Earth, and it would light up, they'd use it to illuminate asteroids and take images of them as they're flying by the Earth. And we don't have that anymore, but they would need to use something like that in order for us to detect them with the kind of things that we're doing right now. So, and like, you'll see some of them will make claims like, 10 light years for Earth leakage in certain frequency domains, but so others are like less than a light year of sensitivity. So it's like, why, why even do that? So yeah, but they're looking, like I said, they're throwing everything at the wall to see what sticks. And then, so in the future, that, eventually, maybe they go from the Meerkat that we were looking at before, here to the SCA. So the SCA, the Square Kilometer Array, is the future of this kind of SETI. And it's called Square Kilometer Array because that's here you'll see 3,000 kilometers away will be the furthest antennas, and the total collecting area should be a square kilometer, I think. Let's see. And it was mentioned earlier about the Murchison Radio Astronomy Observatory by Orange Hue. which is referred to here. Australia's first radio quiet zone was established in 2005 to protect the Murchison Radio Astronomy Observatory. So here, this is the SCA site here. So here, let's bang on this thing here. So this is the one that was being mentioned by Orange Hue. That's amazing. Look at that. But what is that frequency domain on those? 80 to 300 megahertz for that wide field array. Wow. So were people doing any SETI here on the Murchison array? That would be kind of interesting, because that is it's a little higher frequency than some of these other LOFAR ones. So SCA Pathfinder, Murchison, Sun Heliosphere. Yeah, so yeah, SCA. What? $100,000 antennas over 74 kilometers. My goodness. And this is for the square kilometer array for this Australian phase of it. Oh my goodness. That is amazing. Experimental projects. Wow. This looks like fun. I mean, to read on my time, but yeah, I'll check that out in the future. That looks cool. So yeah, so this is the SETI Institute and Jill Tarter in particular. They always had this in mind. As something that, when they were doing the 42 antenna array at Hat Creek, they were envisioning the SCA. So here you could see in this here, you could see that these are this offset Gregorian design. There you go. So that is the future there, that array right there. So it's going to be in numerous countries too. Close this here. And yeah, you'd think with all the advertising, that they would they would do that. Yeah, they're not. It's a kind of a shame. So what I want to do is wrap up that whole thing there. I think that I'm not decided yet on tomorrow night's stream, what I want to cover, but I think I'm undecided. What I was going to do is get into other kinds of SETI, but I'm debating that now. I'm kind of thinking, like here they talk about active SETI and some of these other things with technosignatures. I don't know if I want to touch on this tomorrow. I might go back to regular astronomy stream. I'll have to decide. I'm going to sleep on that and see what I come up with. But what I want to do now is, I think that we should rate out now. And so let me go over here. See who's on tonight. Oh, okay, we could do that. Let's go raid Kimball here. Whoa! Thank you, Mr. Cash. Thank you very much, Mr. Cash. You're awesome. Thank you for that. There. Let me get in here. Let's see. There we go. Let's just get this raid going here. And yeah, so Headspook, yeah, thanks for the nice stream and see you tonight. Yeah, Astronomy Show and chat. Yeah, I'm kind of, I think I'm inclined, everybody, to come back for a regular astronomy stream tonight. And you know, what is a regular astronomy stream? Also, if it's clear here, I may set up the telescope for later for Saturn too. So we'll see how the weather behaves, and you know, that Saturday night, and then you know, we maybe early in the stream we'll talk about astronomy, but we're, you know, if it's a telescope stream, you know, I will be kind of dedicated in the driveway or around my house somewhere, you know, setting that up, and that'll have all of my attention. So I wouldn't want to do anything else anyway. So I want to wish you all clear skies and good seeing out there. Thank you for sitting here through the excellent, that's spooky. Thank you. And yeah, so we'll look in on Saturn tomorrow night, I think, is our goal, weather permitting. We'll see how it goes. I want to wish you all clear skies and good seeing. Good night, everybody. Have fun out there. Kimball Collins is awesome. Go check this out. You'll love it.